Namaskar. Welcome to Prakash on Basics. I'm Prakash Zob. Last time we saw how petroleum is formed underground. Tremendous pressure, high temperature, and the action of anaerobic bacteria converts organic matter, usually dead matter, uh, into petroleum over ages. It flows up around the rocks through non-porous areas and begins to collect in pools because it is trapped between various layers of non-porous rocks. These are usually about a kilometer or more deep down underground. It's a tremendous amount of wealth saved from about 1 million years ago for us to be utilized. Its chances of coming to the surface are pretty rare. Um, some places like Canada or Azerbaijan is where it could possibly be found on the surface also. So we need to drill for it. Random drilling is pretty costly. So a geological seismic survey has to be done. Realize that sound travels through not only air but through ground also, and its speed depends upon the composition of the ground. So what is usually done is there is a detonation of TNT or some explosive about 50-60 meters underground, and the transmitted waves then begin to travel and are detected at various other points. In the process, deciding on the speed at which the waves have been traveling, which can be measured by a lot of different methods, you start determining what is the composition of the ground and what are the materials and minerals that are underground. This is typically what geological survey does, and using this, these various sites where there are large quantities of stored um, kerogen originally that I mentioned, or now that we know of as petroleum deposits, are present. Underground is fine, but if it is in sea, you can't have a blast. So what you do is usually you use ultrasonic sound waves, and they are transmitted down, they enter water, then travel through ground, and they are then reflected back again and measured using microphones that can be used in water, which are typically referred to as hydrophones. And using these ultrasonic waves, then you again determine the geological nature of the material below the seabed, and in this way all these different sites are located. Also, this drilling must be economically viable, so the deposits have to be substantially large um, for extraction to be done through by process of drilling. In India, all this is done by the organization which is known as ONGC, Oil and Natural Gas Commission. Now, then, like a bore well, a well is dug deep into the ground. Various techniques are used. It could be about a kilometer or more deep, depending upon how deep the deposits are. And once these wells are dug, they are capped. The process of extraction is actually a bit dangerous because the whole material is inflammable. Usually crude oil, as I told you last time also, is a mixture of hydrocarbons and contains metal impurities, dead bacteria and other stuff, organic matter also. There are also a lot of dissolved free gases. Because of all this, the crude oil, as it is known, could be either black or brown or greenish red, depending upon what are the impurities like sulfur or iron, etc., and that decides on the color and the quality of the oil that is present. Using high pressure that is applied, the oil is brought to the surface, and the measurement process invariably is in terms of oil is then measured, as I mentioned last time, in barrels. because that was the British system that was used even then. One barrel is about 35 imperial gallons or 42 American gallons. That works out to be 158.987 liters. Um, you can't keep measuring one barrel, two barrel, etc. So the actual calculations are done in terms of how many barrels are pulled out per day, and that is measured in terms of MBD, million barrels per day. Typically, of course, this is going to be for oil rich countries, which are the major oil producers. Once the oil is taken out, it is stored and then shipped and transported worldwide in specially designed oil tankers to whichever required country the destination is. Or it can be sent through pipelines like the one that runs from Alaska through Canada up to the US. And there are other pipelines also. Um, the process of refining and other chemical actions on the crude oil is usually carried out at the place where it is destined to go, because it has to be the buyer's refinery that decides on what the final output of or the utilization from the crude oil is to be done. Before I go into that detail, I must remind you of something that I mentioned a little earlier, because that makes a little more relevance now. Basically, these are all organic compounds. Carbon, as I told you, has four bonds. It's like four arms. Let's say two on the sides and two more like this. And it's a hydrocarbon chain of all the material that is around. The most common pattern is to have one connection everywhere. And so what is usually done is this side and this side, there are two carbon atoms, and there are two spare for this and two spare for this, and one more on the other side and one more on the other side. So all the remaining ones are attached with hydrogen. So if I have only one carbon atom, I would have carbon and four arms, so four hydrogen. So it will make it CH4. That is typically the gas that is known as methane. And if I have two carbon atoms, so two carbon atoms join on, and so three free for this, three free for that. That makes it six hydrogen atoms around. So it becomes C2H6, and that's ethane. And if there are three, then it becomes, think logically, and it will work out that it will be C3 and H8, because three at the end, and the central one has only two arms left free. So this category of chain formation starts taking place, and all such compounds are commonly referred to as alkanes. CH4, C2H6, C3H8, C4H10, etc. These are also typically referred to as paraffins. And in these, typically, there is only one link between each of the two different atoms or ones that are connected. There is a possibility that two of the bonds could hold on to two carbon atoms. And so it will be two bonds of carbon and then hydrogen, or there could be three bonds of carbon and the remaining hydrogen. All such two or more types are referred to as unsaturated type of hydrocarbons. They burn with a lot of dark sooty flames because the carbon starts getting released. Long chains of this sort are formed, but things are not that simple, because I could have suppose 7 or 8 of them, and then instead of having 8 continuous ones, I could have 3, and to the fourth one I could have another offshoot of 2 pairs, or I could have 15 and 7 shooting off at some other angle, and to that 7 another branch. So it's like typical branches of a tree. There is another possibility. Instead of going around in long chains, it could form closed chains or closed loops. Typically something that I talked of long back, like what we have closed chains in RNA and DNA within our body. Or there could be one more very typical pattern. in which 6 carbon atoms form a hexagon and link up 2 3 2 3 2 3 to each other, and 1 1 1 1 1 hydrogen outside. And this is a very typical type of a molecule and a very important one known as benzene. And benzene has a sweet smell, and all these type of patterns are typically referred to as aromatic compounds because they have an aroma, a sweet smell. All these typical patterns that I have been talking of, you could have up to around 2500 different combination of structures that can possibly take place, because all these hydrocarbons that I talked of have chains that are up to a length of around 35-40, depending upon the area from where the oil has been found, about 40 carbon atoms in that chain. So this is the mixture that is available. And after all this processing has been done, from these 2500 that I am talking of, close to 6000 or more items can be made or derived. Big impact on everything that is around us. The whole process then can be split into two parts. First is, from the crude oil you get what are typically referred to as petroleum products, and there is a second step, petrochemicals or petrochem as it is referred to. So you use these products and develop and modify them to make some other more useful products for humans. So what you have is the first step, petroleum products, which is carried out in what is typically referred to as a refinery. The first step is to remove all the impurities like sulfur, which is a major byproduct in these refineries. All other material is filtered out, and then you start processing it. There are 2 or 3 different processes. One is cracking. The second one is distillation. So these are typically situations where you use steam and oil, crude oil, and heat it to a pretty high extent so that everything gets converted to a much higher temperature. It is in vapor form. It is made to pass through big large silos, and gradually the temperature reduces as it goes further down and material begins to condense. This is typically how a distillery works, and depending upon the temperature, different parts of this composition of crude oil starts condensing out, till finally a big solid mass is left in the end. These are typically the one category of refineries that are present. Second type that I mentioned is known as cracking. This is typically a destructive distillation, or what is known as pyrolysis. Sometimes in a different language it is also known as cooking of this crude oil. So what you do is you apply a lot of pressure, and because of this pressure, the nature of material chains that are inside begins to change, and depending upon the pressure and temperature, you can decide on what type of output of these chain lengths can be obtained, and that is very important. And what is the output? About 30% of the output is in form of alkanes, the single long chains, saturated ones that I talked of. That's 30%. Some of it is also gas. I'm going to come to that. Then there is a typical word that is talked of, which is known as naphtha. And so naphthenes is the second major chunk. It's all that oily stuff that is available in crude oil, and that's around 49%. The third important part is the aromatics. That is that benzene and xylene and others that come out as byproducts. That's around 15%. And then there are some waxes, and what is left is typically referred to as asphalt, which is around 6%. The Asphalt is typically solid, many a times more darkish and more of a material that is used for roads and other stuff. I'll come to that. Now, if I drill at a particular place, ratio of all these is going to keep on changing. So depending upon the place, Nigeria would have different, the Saudis would have a different type of crude oil composition that could be extracted. But as I told you, using techniques of applying pressure and suitable temperature, you can modify things as you want to some extent and get what you want out of it. What's important is how many carbon atoms there are. And as I told you, um, if you have 1 to 4 carbon atoms in a chain, you get these methane, ethane, propane and butane. These are all gases. Out of that, the 3 carbon atom and 4 carbon atom, that is propane and butane, are the typical ones that we know and use very often, which is condensed and becomes LPG, liquid petroleum gas, or the cooking gas that we have. Once the chain length goes to 5 and beyond, up to around 17, all this is in liquid form. And once you go from 18 onwards, it starts getting solidified, and around 35 you start getting asphalt and waste products. So that's the typical pattern: 1 to 4 gases, 5 to 17 liquids, and 18 plus is all solids. That's how the original pattern breaks down to. That's not how we use it. So which are the parts that we tend to use? So if it has 9 carbon atoms to up to around 16 carbon atoms, that chain is typically referred to as kerosene. It is also referred to as high octane, because you can, instead of having that area, you could concentrate on 8 area, and then you have 5 to 16, which is typically jet fuel, and you could have 9 to 25, which is diesel, and you could have 5 to roughly around 11, 12, which is typically the petrol that we talk of. The combination depends upon the refinery and the pattern that is decided by the corresponding country. You could have aviation fuel or jet fuel, which is typically more of 8 carbon atoms, and that is known as high octane fuel. So depending upon the requirements, you modify things as you want. Once you cross around 2025, you start getting what is typically referred to as paraffin wax. Just the early stage. In India, for example, we tend to use 5 to 8 as petrol, 9 to 16 as diesel, 16 to 25 as fuel oils, and beyond that a little bit of lube oil or lubricating oil. Actually, many of the factories and other places don't use diesel or other material. They use this heavy oil. Even ships work on this heavy fuel oil or lube oil for running their engines, because they are designed in a different manner. So depending upon the requirement, you start deciding on which particular type of combination of these long chains that you want to use. There is one more aspect that I must talk of, again related to a bit of chemistry. If there are some terms known as functional groups. It's a combination of 2 or 4 atoms or a group of atoms that act as a single unit, and each single unit of this sort has its own characteristic properties. It is possible that you can remove one of the hydrogens and replace this characteristic group, typically referred to as a functional group, in this combination. Typical ones are amines. It's NH2, that means 1 nitrogen and 2 hydrogen combination as one single unit. In our body, that's one of the most important ones, because that's what forms the amino acids within our body. Then there are amides, which is carbon, oxygen, nitrogen and 2 hydrogen as a single unit. And if you use such a combination with two NH2 groups, you get another very important product that we know of, which is urea, which is fertilizer. And there is then NO2, which is nitro group. Where do you use it? TNT, trinitrotoluene. That's TNT. That nitro group can be used in explosives. And then halides. Halides are like chlorine and fluorine and others. We talk of PVC, polyvinyl chloride. So you have nothing but these long chains in which one of the hydrogens has been replaced by a group which is either chlorine. And it's possible that you can replace it by a phosphate group. And remember last time that I was talking of some time back, that ADP and ATP, that was again a phosphate group that is within our body. That's where it has come from, or in all the animals it is there. So that's how it has come into the into nature. So that's how it has to be used again. And phosphates then become a very important part of the number of fertilizers that are made. So you'll find that these are very important groups. So all that you have to do is to start with this long chain and start replacing these groups at different places. You can't do it in the original factory. So you need, away from the original factory, a separate factory setup where these products are taken away and then replacements of these sort are carried out, and that becomes the petrochem industry. So usually you have petroleum products and petrochems that are fairly close enough or linked by the same companies because they have the material ready. Realize one more thing. For all these, there needs to be some single starting block points. These single units are known as monomers. And when you put many of them together, that becomes poly, and that becomes polymers. So it's all just simple jargon of words. That's all. The logic is very simple. So in the refineries, you get petroleum products, you separate them out, take them to petrochemical industries and modify them as you want. These are all well-defined, pure organic compounds. After refining crude oil, usually the base material is either ethylene or propylene other than petrol. And this ethylene or propylene is then reprocessed in order to obtain many of the compounds that are around. The organic part is also separated, and the crude oil part is then converted majority into petroleum products, petrol, diesel, fuel oils, ethylene, ethylene, then LPG, and then whatever remains, asphalt. And don't forget, I told you there is a big major byproduct, sulfur. So what do you get out of all this? You can make fertilizers, you can make pesticides, you can make plastics of a number of types, you can make medicines, you can make different fibers like nylon, you can make adhesives, you can make explosives, just as I was mentioning, you can make resins, you can make various solvents that are used in industries, and so many other factors. And don't forget, pharmaceuticals are also a part and parcel of all this. Detergents, drugs, explosives, perfumes, various fibers, everything is a byproduct of all this. And the word plastic we only know in terms of pollution, but I'll talk of that pollution aspect sometime later. Right now we need to know what its importance is. Some very common plastics that you know come from the most common one, for example, is polythene. It's actually polythene bags that we talk of, and that's polyethylene. I started off with ethylene, as I said, monomer, and then you make a long chain, and then that's what polythene bags are. And then I was just referring to PVC, polyvinyl chloride, and those are the pipes that we use every day, PVC pipes. And nylon, old people, my father and others used to use nylon shirts and so forth. That's a polyamide. Again, it's the same thing. And polypropylene, all these chairs are made out of polypropylene, or many of our food containers are made, food grade plastic is of polypropylene. uh, and there is one more very typical word, if you have heard of this, PTFE, polytetrafluoroethylene. That fluoro is fluorine, and that is the non-stick coating. You always hear of Teflon because that's a brand name, but they are all basically non-stick pans that are made out of PTFE, and that is another important area. And you must have heard of Pearl and other companies. That PET is polyethylene terephthalate. So all those PET bottles etc. are of the same. And then there is another word that we always hear of, polyurethane, and that's the foam that we'll always talk of. And wood protection coatings that are made for wood, all these are all, and thermocol and other stuff. So you will find that everywhere these plastics are in. They are an important constituent of the world that is around us. Medicines, everything has come from this wealth that has been dug out from the ground. Man has been very shrewd. He's utilized the stored energy for his own benefits. He's overdoing it, exploiting it beyond its limits without taking necessary care. But that aspect we will deal with sometime. Realize that we have a very important source for all of us: petroleum, crude oil, black, dark, but highly useful. I hope you have appreciated whatever I have talked of. So please like and subscribe to this channel. Tell your friends about this. Leave a few comments. Leave facts that you have known or you feel are equally important. We'll come back to something equally important next time also. Till we meet again, Namaskar.